On March 14, 1994, Apple Computer introduced its first RISC-based personal computers, Power Macintosh. These new systems have been acclaimed for their high performance, competitive pricing, and compatibility. In fact, they've dramatically changed the price-performance equation for personal computing. But what are the real advantages they offer to business? How well do they fit in with the systems you have in place today? What are Apple's intentions for Power Macintosh and for the rest of its product line? Hi, I'm Russ Christoff, and in this edition of Apple's Seminar for One, we'll explore how this new generation of personal computers can help you improve the efficiency and productivity of your business. You'll see what others have learned, technology managers of leading corporations who have put Power Macintosh through its paces. What are the benefits of high performance? At the Los Angeles Times, they'll tell you why they think Power Macintosh can help them meet their deadlines and beat their competition. How can you bring RISC performance to your custom applications without paying for high-end workstations? At American Airlines, you'll see what they discovered about porting software to run on Power Macintosh, giving them the performance headroom to add new features to mission-critical applications. You've got Macs already. How do you extend their lives and let users move up to high-performance Power Macintosh applications? Howry and Simon, one of the nation's largest law firms, will tell you why they're upgrading to Power Macintosh. Microsoft Windows running on a Macintosh? Sounds like the best of both worlds, doesn't it? At Monsanto, you'll see how Power Macintosh can be a way out of the cross-platform dilemma. We'd also like you to meet some of the people behind the creation of Power Macintosh, and we'll visit the Somerset Design Center in Austin, Texas, where Apple is working with IBM and Motorola to design PowerPC microprocessors. We'll talk about applications, too, how your old ones run on the new platform, what you can expect to see in new applications designed specifically for RISC, and the development tools you can use to build custom applications optimized for Power Macintosh. That's a lot to cover, so let's begin by visiting with Ian Diary, Apple's Executive Vice President, to hear why Apple decided to create the Power Macintosh and what the plans are for the future.
Let me just give you a quick overview of our strategy, and that is to be a technology leader with price-performance advantage. If you've looked what Apple's done over the last 10 years, is that we have coaxed and cajoled the industry forward in innovation. We have led with innovation and people have scurried to catch up with us. It started back in '84 with the introduction of GUI, the graphical user interface, where actually people at the time, you remember, said, how unimportant that was, how unnecessary it was, and people rushed out to copy us. Then again in '87, we introduced color and expandability. Everyone said, who needs color? Everyone rushed out to copy us. And then again at the end of last year, we introduced the AV technologies. Again, coaxing and cajoling the industry into multimedia. And now we're doing it again in '94 with the introduction of PowerPC. With the taking of the RISC chip, which hitherto has only been available at the high end of the computer industry, bringing it to an implementation at the personal computer end of the industry at affordable prices, combined with a volume operating system such as the Mac OS, is shaking the industry to its roots. And suddenly we have the power of RISC available to everybody. So we'll start to include as standard many advantages that are just a dream or a twinkle in a lot of other companies' eyes. The difference of our implementation is that it'll have the famous Macintosh OS on it, with a large number of native applications, with tremendous compatibility backwards with our own Macintosh applications, 68,000 environment, but also extending that to Windows applications, so people can come from the Windows environment and bring their favorite or Windows applications with them and run them at very, very acceptable speeds. And on top of that, move information between the two environments. Now that's unique. You've seen how quickly our competitors are scurrying to try and talk about how powerful their chip may be soon. And that's a classic example of Apple driving the industry forward again. Therefore providing a service not only to our customers, but to the computer industry. That's something we will always endeavour to do. And I think that is a fundamental reason why a lot of large customers have confidence in Apple. It's because we continue to strive to make better the environments that they operate in and that we operate in.
Power Macintosh brings to the marketplace the power of workstation computers, the affordability of mainstream personal computers, and the capability to run applications for Macintosh, MS-DOS, and Microsoft Windows. For the first time, the power of RISC joins a mainstream personal computer operating system, Macintosh System 7. These are very fast machines, as we'll demonstrate in a few minutes, but Apple didn't bring this new technology to the desktop just so you could do what you're doing today faster. Performance for its own sake isn't the point. It's the means for delivering new capabilities for making computers both easier to use and more useful. Here's what some of Apple's people have to say about what the PowerPC architecture really means.
What our customers want to do is be able to use the computer more as something that extends themselves and lets them get more done during their workday.
The customer is going to do things a whole new way.
What's neat is that the PowerPC chip is an enabler.
Things like interacting with the computer more closely, using it as an interface to their telephone system.
With today's computers, we use very simple inputs. I can type on the keyboard or I can move the mouse. With more powerful machines, with the enabler of the PowerPC chip, we can go to a richer range of inputs.
The best computer interface ought to be invisible, one that you can use just like you communicate with people.
We should be able to make interfaces that much more closely resemble the real world.
Instead of point and click, we have ask and tell. Instead of having a tool that you have to tell every step of the way how to get a job done, you simply tell it what you want done, and the Power Macintosh is there to execute it for you.
I'd like it to show me dramatic visualizations so I can truly understand what is happening.
You're not going to be looking at dead documents anymore. You'll be able to pick up an object in a catalog and rotate it and look at it. You'll be able to play a movie or a training film right in a document.
What we're doing with our architecture is trying to make all of these new kinds of information, multimedia information, video, sound, things like simulations, just an everyday part of life.
For the first time, I can truly interact with a rich, perceptual experience.
In 1984, we delivered the Macintosh, and it was a revolution. In 1994, we're doing the same thing with Power Macintosh. But this time, in addition, it works with everything else in the rest of the world.
Here's the brains of the new Power Macintosh personal computers, the PowerPC 601 microprocessor. It's a product of an historic alliance formed in 1991 between Apple, IBM, and Motorola. And it's only the first in a family of chips that will enable Apple and other systems companies to offer RISC performance in everything from sub-notebooks to servers. Now, in this segment, we'll visit with Jim Gable, product line manager for Apple's Power Macintosh computers. Then we'll visit the Somerset Design Center in Austin, Texas, where these chips are being designed.
Our engineers recognized a couple of years ago that to keep growing the platform and to really reset our foundation for Macintosh, we'd have to move to the new RISC technology. The advantage of the RISC technology is not that the old technology is bad. Chips like the 68000, the x86, those chips are fine. They continue to be fine. But what you see when they're moved to the new generation of performance, like the Pentium chip, is that chip is very large, it's very complex, it's very expensive. So yes, you can push the old architectures forward, but it gets increasingly difficult to do. The advantage of going to RISC is you really start to the ground floor of a new architecture. When our engineers decided that we wanted to go to RISC technology, we really looked at every chip available in the marketplace. And those vendors were all really interested in talking to Apple because we have such high volumes, especially compared to any workstation environment that's out there today. We chose IBM with Motorola for a couple of reasons. One, you have great economic power with those three companies working together. So we have a family of PowerPC chips being designed in parallel, 4 different chips as of today. Also, Motorola and IBM have some of the best manufacturing capabilities in the world. So not only can they do high volumes, but they can do technologies that are ahead of their competitors. So that's also something that we've gotten access to by using PowerPC.
When we formed the alliance, when the companies came together, they came together hoping to promote and push a change in the computing paradigm that we have today.
We're not in here just to get PowerPC to have like 10% of the market. We want to dominate the market. And the way to do that was to, rather than serialize the introduction, introduce these 3 processors or 4 processors initially that addressed the entire market, from portable computers to desktop machines to server machines.
There are 4 initial members in the PowerPC family. The 601 is our very first offering. It was designed to offer the developers of both hardware and software their first implementation of the PowerPC architecture. We will follow that up with our next generation, which includes 3 different microprocessors, the 603 being targeted for portables and entry desktop. The 604 is our second generation desktop machine, and the 620 for servers. So we'll end up having 4 members in the family within the first couple of years of PowerPC. And that allows our customers a broader product offering and a more finely tuned product offering. They will achieve more performance at the upper end. They'll achieve lower power at the low end. RISC is simply about making the microprocessor simpler. We've designed a computer that is fewer instructions, and those instructions are easiest for us to build microprocessors around.
Microprocessors can be thought of as a Tetris game. And if you're familiar with Tetris, it's a game where 4 squares come raining down the top, and these 4 squares can be in various shapes and forms. You can think of a CISC instruction being like the series of 4 blocks raining down to the machine. And when the game is over, you're stuck with a bunch of holes, which can be thought of as lost performance. In RISC, it's like playing Tetris with a single square, where the square comes down and just locks into place, and things execute, and you end up with always winning the game, which is the idea behind RISC.
We've also added the additional capability of allowing us to execute more than one of those instructions per cycle in the machine. So what we end up with is essentially a simpler instruction set, maintaining the strength of those instructions that are most oftenly used, with the ability to do them more than one at a time. The microprocessors being smaller, we can therefore sell it to the market at a lower price, and that price ends up in a lower cost PC. People here are organized into what we call tall-thin design teams. A tall-thin team means that the individuals have ownership of a section of the design.
Each team has all the skills and resources within that team to get their job done. A typical design team will have a logic designer in it, a circuit designer, a layout person.
They're responsible for writing the high-level specification, for working with the customer, for reducing that specification to a more detailed implementation that we can go build, and for actually building the actual mask and checking those masks. They take the design from top to bottom. It gives the employees more pride in what they're working on. It also gives us the ability to make decisions concurrently. We can have each of these teams running in parallel instead of having to serialize their efforts.
Our record has shown that we've been pretty darn good. Both of the chips that have come out as a result of this to date, have come up and within hours have run on either Macintoshes or IBM RISC systems.
All the work we're doing is in a 0.5 micron CMOS process, which is state-of-the-art manufacturing facilities for both of our companies. We've had to work together to achieve that process for both Motorola and IBM. We have a common manufacturing process that we had to set up in both facilities.
If you look at where the major semiconductor players are today, there are very few that have been actually able to transfer half micron out of the lab and put it in a manufacturing environment to where they feel comfortable in setting up manufacturing parts on this technology. MOS 11 was constructed as the best facility we know how to build. It's capable of delivering half micron, 0.35 micron, and we believe the facility could even deliver quarter micron products in the far future. But we plan to convert the world. We want to deliver twice the performance as what the rest of the industry has to offer. We've got people excited about making this happen. We're going to pull it off, and we are going to turn the industry on to PowerPC and make it an industry standard across the board. And I hope to build 30 more factories just to build the PowerPC parts. That's what I'd like to do.
Apple's new Power Macintosh computers use versions of the PowerPC 601 chip running at up to 80 megahertz. IBM and Motorola have announced that a 100 megahertz version of the 601 will ship in volume in the fourth quarter of '94. The PowerPC program is moving ahead right on schedule, and as the new chips become available in volume, they'll be used in future Apple products. The 603, for example, designed for low power and mobile systems, will be available this summer.
The key for PowerPC with Macintosh is that we've really decided to push this throughout the mainstream of our product line. This is not some sort of high-end offering that'll just be available for high-end users, but we've really set up our whole business so the next couple of years we can push PowerPC throughout the entire line. From a business perspective, it's important to remember that Power Macintosh is just part of the Macintosh family and joins the family just as once upon a time the 040 did and the 030 did. In fact, we will introduce new 68,000 Macintoshes even after the introduction of Power Macintosh, because we know that bringing PowerPC throughout our product line will take a couple of years. And lastly, on the software front, we're doing the same thing. We're planning in our system software to support both 68,000 and PowerPC-based Macintoshes for years to come.
Let me formally introduce you now to the latest members of the Macintosh family. There are 3 models of Power Macintosh available at this time, with various configuration options. The most affordable is the Power Macintosh 6160 in a slimline design. The Power Macintosh 7166. This unit is ideal for general business computing, and its design is based on the popular Quadra 650. And the highest performance model is the 8180, clocking in at 80 megahertz. The Power Macintosh is still a Macintosh. It runs a version of System 7 that to the user is identical to the operating system they're already familiar with. But portions of the OS have been optimized so they run more expeditiously under the PowerPC RISC architecture. Your existing Macintosh applications continue to run on the Power Macintosh at speeds up to a Quadra, even though they were written for a completely different microprocessor. Here, for example, are 68,000 versions of some major products: FileMaker, WordPerfect, Excel, and here's a calendar, now up to date. You can keep using your utilities like Norton Utilities. Screensavers and other software that tends to depend on special features of the computer continues to run. And if you're interested in Power Macintosh for your home, you can still play the same versions of your favorite games. Tremendous performance improvements are gained with new versions of applications that have been optimized for the PowerPC architecture. Let's see how these systems compare with the competition. First, we'll square off our Power Macintosh 8180 with a Unix workstation that costs 3 times as much as this Macintosh. We start both devices at the same time, each running its version of a technical computing application called Mathematica from Wolfram Research. Each system is drawing a complicated shape. When the Power Mac is done, the workstation is still computing. So now, for the price of 1 Unix workstation, you can buy 3 Power Macintosh 8180s and get better performance. Intel's high-end chip family is the Pentium. Here we have a compact Desk Pro 560, which runs on the 60 megahertz Pentium. And we're going to compare it with our midline Power Macintosh, the 7100, which runs at 66 megahertz. Now, we're comparing these two machines because they're about equal in price. An application that artists use to create and manipulate images is Painter. This is from Fractal Designs, and we have the Windows version on the compact PC and a native Power Macintosh version on the 7100. We'll start both machines at the same time. With Painter, you can set up a session to perform a number of operations in sequence. We're adding a surface texture to this image, which the Power Macintosh has already done. Then we'll create a lighting effect. And finally, add a motion blur. And the Macintosh finishes all three operations well ahead of the Pentium box. While the compact machine is fast, it's no match even for the mid-range Power Macintosh 7100. The reason is the microprocessor used by these machines. When it comes to handling basic computer functions measured in integer performance, the PowerPC 601 chip is about equal to the Pentium. But where the PowerPC architecture really shines is in floating point performance. Both the Pentium microprocessor and the PowerPC 601 have built-in math coprocessors, but the Pentium specs out a little less than 57 floating point spec marks, while the PowerPC 601 checks in at more than 80. Now, this is the measure of the speed at which the chip crunches numbers, runs graphics, video, voice, and so on. The very compute-intensive jobs that are redefining what computers do for us and how we work with them. An independent test by Ingram Labs measured performance on 24 different tasks, including loading files, scrolling, spell checking, applying filters, and so on. Their results show that the Power Macintosh 8180, running native Power Macintosh applications, beat the Pentium Desk Pro, running Windows applications, by 60%. In fact, on some compute-intensive tasks, the Power Macintosh outperformed the compact by over 300%. It's interesting to note that the 60 megahertz Macintosh 6100, which outperformed both of the Pentium systems, costs over $1,000 less than the 60 megahertz Pentium machine. Well, those are the numbers. But what can this performance mean to your business today? The Los Angeles Times is one of the largest circulation daily newspapers in the United States, and they were eager to try out Power Macintosh and some of the native applications that are available for it.
Our staff produces stories that are wondrous storytelling. And for a long time, the paper was known for that quality almost solely. Over the last 4 years, the introduction of the Macintosh has helped us make this a place that's also known for its color, for its graphics, for its photographs, for the idea of reflecting a world that increasingly is visual.
Last year we output 6,000 pages of color using this very system. We currently have color on all of our section fronts. We have 6 separate editions.
We're serious. We're a serious newspaper, and we do detailed graphics. We do medical graphics that show extremely fine work. It gives our graphics a look, I think a serious kind of feel that you can't do if you've got underpowered equipment. And I like that look. The editors here like that look. So immediately you run into a problem of whether we've got the hardware to meet that kind of demand. When we got the Quadra 950s, we thought this was the ultimate, and within 6 months the artists were already hitting the upper limit of how fast they could be on certain documents. I sat down at the Power Macintosh with a document that I was completely unable to open on my FX in under 10 minutes. So I thought, this is a good one to look at. I was able to scroll sideways, up, down, zoom in, zoom out, change text, delete elements, restore elements. I was amazed. I sat there with my jaw hanging open. Having some of the artists sit down and test it across the room, I could hear little exclamations of, wow. And well, did you see how fast that is? Look at this. I just put this picture in, and here it is. It was almost fast, too fast to clock. It's really an amazing thing.
The Los Angeles, Southern California area is composed of a multitude of cable systems. We produce some 24 books that service those systems, plus a generic book for other areas. And it's very complicated to do. We need to have key people working on it and very fast, responsive electronic components to service.
I think the Power Macintosh is absolutely phenomenal, and the reason I think it's phenomenal is basically because of speed. For instance, on an Adobe Photoshop scan, when you're rewriting it to a different format. And on my machine, it takes 2 to 3 minutes to do. On the Power Macintosh, it does it instantaneously. I don't even see it rewrite itself. As far as rolling in our information, we lose 2 to 3 minutes per document now because our information is re-rolling, especially when it comes to the grids. They re-roll very slowly. With the Power Macintosh, they're instantaneous. They do it immediately. Saving 2 to 5 minutes on a document will enable us to save an hour during a day, and that hour can be used to make our book better, to make it more readable, to add new features, to do things that our readers want.
The faster the system is and the more reliable it is, the more we can do that and the better we serve our readers, and the readers love it. All of our photographs are handled on the Macintosh. We use color, we use black and white, and combinations thereof.
We're moving away from a chemical lab. We still soup or develop the film, the negatives. Then we scan the negatives into the Macintosh system that we have.
Pictures are a real problem because of their size. We can't use a low-res version, and that's an awful lot of screen time to deal with those. So I think that is probably the biggest issue that the Power Mac deals with, is the way we use pictures.
I've asked all of my department heads whether speed is important. And of course, to a person, as we go around the table, the photo person says that's what we need because we can get the images scanned in and moved along faster. The person who does design work says that's what I need. The person who is dealing with our pagination project says this is where I really needed it. Every one of our processes involves an element of bringing things over, moving it around, doing something to it while it's on screen, moving it along to the next workstation. If you can think of it in assembly line terms. Does it matter how fast the belt works? Yeah. Does it matter whether you can have a mechanized way to assemble the wheel? Yeah, it does matter. If these things were not possible, we would lower our expectations. Now we see that they are possible.
As we've been stressing all along in this program, performance is as performance does. Apple will be taking advantage of the Power Macintosh's speed to enhance its operating system and to offer new and valuable services. Software and peripheral vendors are developing new products and refining existing ones to put this power to good use. Here's a list of over 150 software companies, for example, that have expressed their commitment to deliver versions of their products optimized for the Power PC chip. They're not obscure outfits, as you can see, but include the major vendors of software for general productivity as well as specialized markets. Their products will not only run faster, but the high performance of Power Macintosh will allow them to improve the user's experience and to add features that simply weren't feasible before. We talked with Pete Higgins, Senior Vice President of Software Development at Microsoft Corporation, about what his company thinks of the opportunities presented by this new architecture.
We're very excited about the Power Macintosh. It's a new generation of power for the Macintosh. It will allow us to do great new things for our applications, make our new family of applications even better. We'll be creating Power Macintosh versions of Microsoft Office, including Word, Excel, PowerPoint. We'll do Microsoft Works, Microsoft Fox Pro for the Power Macintosh by this summer. One of the real advantages of more power, such as machines like the Power Macintosh, is we can use that power in ways that will make the software easier. We're going to use that power in subtle ways to do more thinking, to present the software in an easier way and make it much friendlier and easier. IntelliSense is a capability we're building into Office for our own individual applications that it really is designed to meet that need. A good example is autocorrect in Microsoft Word, where we're able to, on the fly, fix a lot of the common typing errors. And in fact, the autocorrect will get smarter over time, and the words that you as an individual misspell we can add it to the list and we'll fix those for you automatically. Over time, we'd like to build software that adapts to each individual. It notices what type of formats you use. It notices what certain words mean to you. It notices how you tend to format things, and we'll do that for you automatically.
Another major software developer is Aldus Corporation.
We're moving all our applications as quickly as we can to the Power Mac. By the end of this year, we expect that we'll have more applications for the graphics professional on the Macintosh than anybody else. I think that any developer that looks at this very seriously is going to come to the same conclusion we did, which is that this is a big opportunity and they've got to move their applications as quickly as possible, both from the perspective of their own development tools. I mean, just the process of making products on this is much faster, as well as from the point of view of their customers. In our marketplace, which is primarily the graphics professionals, performance is a key issue for a number of reasons. One is they end up spending a lot of tedious time manipulating graphics and images, which get in the way of creativity. So something like the Power Macintosh really changes the tools they use and improves their creativity tremendously. The increased performance of the Power Mac is going to affect the functionality. We're moving very heavily on the workflow end of things, because that's really, with this additional performance, that's the next big leap, the next big productivity opportunity, is once you've got the work of a group coordinated and managed with workflow capabilities, you can really have a lot more, not only performance, but a lot more handles into why things are working and why they're not working.
The prospect of delivering new capabilities on a low-cost platform with a large potential market is really capturing the imagination of software vendors. Now, here's an example of the type of things that are coming to market. This is LogoVista EJ, being used to translate this document from English to Japanese. Doing this sort of thing used to be a challenge even for a mainframe, and desktop versions just ran too slowly to be used routinely. But now, language translation can become commonplace on a desktop because Power Macintosh reduces the time it takes by a factor of 10. It isn't just shrink-wrapped applications that can benefit from the improved performance of Power Macintosh. In our next segment, we'll visit American Airlines, where custom-made Macintosh applications have been used for years to control flight operations, crew assignments, load balancing, and other mission-critical tasks. Since this video was photographed, American Airlines has decided to replace their flight dispatchers' workstations with Power Macintosh 8180 systems, rather than move to Unix workstations. The key reasons for that decision? Superior price performance and the ease of porting existing applications.
American Airlines is about the biggest airline the world has ever seen. We own about 650 airplanes, fly about 2,400 flights a day. We never stop. 24 hours a day, 365 days a year. The System Operations Control Department, and the center out of which they operate, is the nerve center of the airline. We were the first airline to design and build this kind of complete, high-tech, integrated center to run a major airline. Prior to 1990, a dispatcher or a crew scheduler had a terminal. And as the airline grew, it became more and more important that we process the data in a way that would enable a person to absorb more and more at a time. The Macintoshes that we brought in here 4 years ago in 1990 were by far the best machine for the problem at that time. In fact, in 1990, there wasn't another machine that gave us the same combination of what we call Sabre emulation, that is the ability to be a full-service terminal on our Sabre and flight operating systems, and to run, at the time, relatively sophisticated decision support programs. The aircraft situation display is a graphical display of satellite data that tells us where every airplane is.
It takes information from the FAA's aircraft tracking system and updates it about every 4 or 5 minutes, exactly where the airplane is and the altitude and other pieces of information. And we take that information and interface it with our own flight operating system and then present that as an aircraft icon on a map.
Every time we talk to a user, there's more things that they would like to add to the particular feature or look at the data in kind of a different little way.
Well, what occurred is, as we tried to track all of our flights at one time, it would just gradually bring the workstation down to where it's very slow so that you could not do any other type of work. So, in fact, what we've done is that we have just outpaced our current machine, so to speak. We just flat ran out of power.
I mean, when you think about it, we've really gone for 4 years with the same workstation, with excellent reliability, and it's given us the growth room that we needed. But we're at the end of that right now.
So what we were looking for was increased processing power that had a good cost performance curve for us, both in the price of the hardware and in our ability to run in increased power on the new workstation platform without having to do a lot of code rewrite.
A critical issue for American was how easily their custom-built applications could be optimized to run on Power Macintosh. As part of their evaluation, they ported several of their flight monitoring systems.
Flight Monitor was done in approximately 2 weeks, was recompiled to run on Power Macintosh. The weather application was done in an even shorter period because we'd learned how to do it.
The code that we had written was done in Mac App, and that ported fairly readily. It involved primarily a recompile and changing bit alignments of various data types. There are some things to learn, but it's certainly not rocket science either. It's primarily sitting down and going through it, and Apple provides some very good tools that actually will take a look at your code, and it actually makes recommendations about what you should do to change your code to get it ready for PowerPC and for compile under the new compiler. Well, the application, Flight Monitor, after we recompiled it, Apple had told us to expect somewhere between 2 and 4 times the performance we had seen on 68K. Our experience has been, in not a very formal study, but just kind of stopwatch draw speeds and that sort of thing, has been more like 5 to 6 times performance increase.
And the difference is startling. You have to watch the PowerPC because if you watch the other machine, the PowerPC is done before you look over.
The picture we see from Apple is a very, very positive one, and we're very impressed.
We expect that we will never stop developing new system decision support tools. And so I think we will never stop probably wanting more power on that individual workstation.
We probably could not be as big, and we certainly could not be as efficient in managing the irregular operations that we do without these tools. This past winter, we had storm after storm after storm. These tools brought us through those storms in materially better shape than certainly we could have without the computers, and we believe that most of our competitors came through them.
To develop native Power Macintosh applications or port existing software, you can choose among tools from Apple and third parties. Now, these range from object-oriented languages like C++ to fourth-generation languages, visual programming tools, and database query tools. The first of these tools to be delivered primarily targeted commercial developers, so you'd have a wide range of off-the-shelf software available to purchase. Today, we're just beginning to see the first in a wide range of development tools specifically targeted at the needs of systems integrators and in-house programmers. Over the next several months, many more tools will become available. Let's start with the programming tools that commercial software vendors are using to bring their own applications native. Apple's basic Power Macintosh System Development Kit runs under the Macintosh Programmer's Workshop. It lets you build applications in the familiar MPW environment, then compile them for Power Macintosh. Another popular development environment for commercial as well as in-house developers is MacApp, Apple's C++ framework for object-oriented development. The Power Macintosh version of MacApp is what American Airlines used to build its graphical flight control system. With Code Warrior, you can build Power Macintosh software in C or C++. It provides a class library, interactive debugging, code management tools, and integration with MPW. Code Warrior allows you to compile applications for Power Macintosh and 68K Macintoshes from the same source code, an important consideration if you're developing new applications that will run on both platforms. You can also build native applications by working in a completely visual environment. This is a client-server application for San Francisco-based Montgomery Securities. It's used to enter trades for buying and selling stock. The Macintosh client was developed with Prograph CPX, and it accesses information stored centrally on an AS400 server. With Prograph CPX, a tool from Prograph International, you program pictorially. Prograph includes an object-oriented framework, and it's cross-platform. You can target Power Macintosh and 68K systems in one effort. It's a rapid application development environment for building client-server or standalone applications. With graphical interactive debugging and object editors, Prograph CPX is geared to fast prototyping. Many software vendors are bringing their fourth-generation development environments to Power Macintosh. One of the most popular, Fourth Dimension from ACI, will not only be native, it will become cross-platform, ideal for large organizations with mixed environments. This powerful 4GL offers access to a wide range of relational databases. Virtually all major corporate database vendors are also bringing their products to PowerPC. Many have already shipped client drivers, and their PowerPC database engines are forthcoming. Native client-server products will boost database performance over the network. And to query databases easier and faster, popular tools such as GQL, that's Graphical Query Language, from Andyne Computing are also going native. GQL reporting tools will run faster, and because GQL is cross-platform, your organization can simultaneously target Power Macintosh, Windows, and Motif. So you have a lot of flexibility in your Power Macintosh development alternatives. And as American Airlines learned, some of your existing applications or parts of applications may not even need the extra performance of native mode.
The only place you're forced to go to native code is if you've got applications that actually demand that kind of performance. And so as we have to have increased performance, for stuff we'll write, we'll port it. For things that we buy off the shelf, as vendors come out with upgraded products that are native, we'll buy those if they're necessary. Otherwise, we'll run emulated.
For years, Apple has been working very hard on making Macintosh fit into a mixed environment. Well, with Power Macintosh, we take it another step forward. Through an application called Soft Windows, you literally have a DOS Windows machine inside your Power Macintosh computer. The way it works is pretty interesting, too. It's built on an emulator technology from Insignia Solutions, which, by the way, is the same emulator technology that Microsoft uses in Windows NT. With this emulation technology, you can run DOS applications and Windows applications on top of it. And really, when you're in Windows, you can make it fill your screen and it looks like you're on a Windows machine.
Soft Windows is available as a bundled option on Power Macintosh systems. It's a complete implementation of Windows 3.1, and it runs MS-DOS as well as Windows applications. As we're recording this video, Soft Windows supports the 286 instruction set, but Insignia is working on support for 386 and 486 instructions as well. We offered the folks at Monsanto Agricultural Chemical Company a chance to try out Soft Windows on Power Macintosh. Here's that report.
We have a very much of a mixed environment, and that's probably one of our strengths, is our ability to have computer services and provide a mixed environment to meet the user's needs. The two primary platforms, obviously, are the PC side and the Macintosh side.
We deal with the EPA and other various regulatory agencies on making sure that AG's products are registered so that they can be sold. Our group decided to go Macintosh because of its ease of use. However, we do need to be able to access PC-based applications. For example, our budgeting is a PC-only based application, and we need to be able to get into that on a monthly basis and pull information from there.
Soft Windows is a very nice product. It provides a full Windows experience for the Macintosh user who probably has only heard about Windows before.
Soft Windows is very easy to use. You just basically double-click on an icon and it starts up, and you're into Windows. And we have Norton Desktop running on top of Windows to make it even look more like a Macintosh. And it looks just like the machine, a 486 machine that's sitting next to it.
Having soft Windows is going to provide a way to bridge so that the user can migrate from one platform to another and still be able to bring along with him a lot of his applications.
Power Macintosh will let someone who wants to be on a Mac, but still run the PC and the DOS applications that they need to run.
If they're used to running the applications on a DOS machine, they'll find that they're able to run those programs just as they were before. They load them onto the disk just as they did before, and the results are identical. The speed is equivalent to a souped-up 386, which is something that most people will be very happy with. And you have all the advantages of being on a Macintosh.
This is a machine that'll finally do what I want to do, and I don't have to buy two different boxes to do it. You don't have to throw away all your old applications or old macros or all the other development or the forms or templates or everything else that you've developed.
One other advantage of going to the Power Macintosh is that you can take the results that are generated by your DOS-based programs and immediately paste them into your Macintosh spreadsheet or word processor packages and eliminate the need for either transcribing results by hand or other mechanisms such as inserting disks and transferring them back and forth.
I mean, soft Windows, either using PC Bench, which is a standard benchmarking used by either PC Magazine, or within Norton Desktop, it benchmarks out at a 486, 33 megahertz machine. It has the look, feel, and performance of that machine.
Well, we already know how good Macintosh is at running multiple protocols. Support costs are far less than they are getting multiple protocols to work on the Macintosh than they have been on the Intel PC side.
What Insignia has done with soft Windows is they're getting all of their network connections and everything else being passed up from the Macintosh layer. So underneath everything, they're getting the network services and print services being brought up from AppleTalk, which you don't need to worry about the addressing. Being able to run LAT, DECnet, IP, AppleTalk. And basically any protocol can be easily added just by adding the appropriate CDEV and rebooting your machine, and you're there. You don't have to do all the configurations, loading it high, loading it low. You don't have to play with those, don't have to worry about the interrupts. So there are a lot of issues in the Mac that just disappear. With soft Windows and the Power Mac, you're kind of getting the best of both worlds. The traditional Macintosh, you're getting the Power PC there with your native apps, and you're also getting your entrance into the Windows world, being able to deliver those applications.
People that are using Intel machines right now should consider what applications they're running, consider the cost of purchasing a new Intel-based platform. The Power Mac comes in at a very competitive price position where you can buy two platforms for the price of one, literally, and the performance is only going to get better.
Power Macintosh is pretty intriguing, but what about the Macintosh personal computers you're using today? Apple has a variety of upgrade options that will give many earlier Macintosh models the full functionality of PowerPC technology, both full logic board upgrades and lower cost processor upgrade cards. And Apple is working with third-party developers who will provide an array of options. Let's see why one Apple customer chose an upgrade strategy rather than replace their systems.
We have about 700 Macintoshes on a wide area network that spans the entire country. We have 40 of our clients connected digitally. There are significant reasons why we are excited about the Power Macintosh and why we're moving towards that platform very quickly. There's a lot of services that we want to provide to the desktop that we currently don't have the capability to deliver. And also, it's a part of our general strategy of upgrading our infrastructure. Apple has always made upgrade paths available, and this is another one. And we've always taken advantage of that. And because of that, we think that our long-term cost of this platform has been much lower. Our goal in the 90s is to provide more services to the desktop using a much simpler interface, using much simpler navigation tools. So we simplify the front end, but we add complexity to the back end. And in order to do that, you need much more computing horsepower.
We have never had any hesitation and continue to have no hesitation to invest in any additional technological resources which will make us more efficient, more powerful, more capacity, quicker. Technology is a substitute for time. If you can eliminate time, you reduce the cost of legal services.
Now we're in a position where we can upgrade our entire platform at a very, very low cost. There are two upgrade paths. One is an upgrade card. The advantages are you still have your 68,000 based microprocessor, onboard video, all that kind of stuff that you rely on today. Plus you've now got a PowerPC daughter board that's giving you essentially clock doubling performance. Essentially it's just opening up the case and installing the upgrade card in the PDS slot and installing software to let the operating system access that card. The other is, and the path that we've chosen, is to do a complete board swap. The main reason for upgrading the current Centris and Quadra machines with a complete board swap is we see that we're getting a complete new computer. So very inexpensively, we're upgrading our entire computer. By upgrading those particular boxes, we feel, from a financial standpoint, we're going to prolong their life. And if you look down the road, into the fourth year of their life, we're going to be in a position where we're going to really be at a real profitable position in these machines instead of having to start acquiring new technology and incurring that extra depreciation and therefore impacting our bottom line.
Well, we're very excited about where we stand now at our law firm and the technological investments we've made. Our investment in technology over time has given us a competitive advantage, has made us more attractive in the marketplace. We have absolutely no doubt about that.
Anybody with the slightest interest in technology has heard about the information superhighway and digital convergence, about the new ways we'll be using computers in what many think will be the very near future. Multimedia, now pretty much a medium for specialists, will be a commonplace form of communications. Our telephones will be tied into our computers, bringing us global video conferencing that will seem as ordinary as a local phone call. Virtual reality will not be a toy, but a tool for physicians and other professionals. Intelligent agents will do our superhighway channel surfing for us, returning information that will help us run our businesses with greater efficiency and success. It's that kind of world that Apple is steering toward with its historic move to RISC computing. Not because it's compelling to computer aficionados, but because it's a worthwhile destination for all of us, and because our customers tell us it's where they want to go. Apple believes it's time for a new personal computing option that will be a safer, more secure choice as technology moves forward, that will provide performance today and room to grow in the future. Remarkable people have done remarkable things with Apple's products over the years, and Power Macintosh provides the vehicle for that creativity to continue. I'm Russ Christoff. Thanks for watching.